Claire, I'm glad we got you back, but I'm slightly disappointed that you didn't bring any toys with you this time.
Yeah, I'll keep them for next year.
Okay, that's good, because we're actually going to cover a lot of ground here, because both of you do, I would say, different but complementary things. Joshua, do you feel like that's an apt description?
Absolutely. So, hi, I'm Joshua Wilson, the co-founder and CEO of Freedom Robotics. We build the software building blocks to make it so that you can focus on your product and not spend 90% of your time working on the software infrastructure for it. So we handle the software side.
You build the hardware building blocks, is that about right?
Correct. So we are building the software and the hardware required to operate a brain at very high velocity. Yeah.
So we brought you together to talk about startups, you know, the sort of the difficulty of launching a robotic startup, why so many fail, because I suspect that there are a few folks in here. Do we have any founders in the audience? Okay. Backstage, we're surrounded by founders. So let's get sort of the kind of depressing, difficult part out of the way first. So, you know, obviously, again, in recent years, we've had a number of pretty high-profile failures, Rethink, Anki, Jibo, you know, I can go on and on. Why do so many robotic startups fail?
Because I think, first of all, the simple fact we say a startup in robotics is already a bias towards technology. And in general, a company needs to be about a business, not about technology. And each time we have seen companies starting with just the technology, either they get acquired if the technology is very good, but they never end up becoming a business. And so I think it's very important to always measure what is the added value of the product in the end, and compare this value to the investment that you need to build this product, and to the price of the final product. And I think it's just very hard to solve robotics problem today, which make it still very expensive and very hard to get to even an MVP in the development cycle of the company. Too many people focus still on robotics problem, not on the final problem, not on the business proposition.
So, I mean, Joshua, I think you're kind of close to this from the standpoint of you know, running a startup. What are the biggest stumbling blocks for robotic startups?
Yeah, I mean, I think similar to what Claire was saying, when you go to start a company, there are only so many problems you can succeed at, and so many things you can focus on. And modern startup theory, lean startup theory, says the problem you should focus on is fast iterations with your customers. Right now, looking back 5 years, how do you do that when you're having to build hardware, having to get that hardware work in the real world, having to source components and scale your business from manufacturers who are building and shipping prototypes that you're building?
So you feel like the vast majority of robotic startups right now are coming out of the gate just attempting to build the full stack? Well,
so last year on stage, there was a VC who said he was on a panel, who said he was tired of seeing all of his portfolio companies spend 90% of their capital rebuilding the same software stack. And so I think looking back, that was the case. Now I think times are changing. Today,
over the past year, there's been a
tremendous amount of work, and you see companies like mine, but also work that NVIDIA has done, where you can run one line of code from a company like mine, get up and running with a piece of hardware that NVIDIA does, and you can do that on some of the robots that are outside right now.
And is that a plug? There are actually robots outside that are being run
with NVIDIA stuff, with our stuff.
With both of your stuff, yeah.
But also the more important point is that it is as easy. Those things are starting to work together. And even a year ago, every robotics company I interviewed was doing a fully integrated vertical stack. And that's just a lot of work.
So if we make a comparison, let's say, to the phone business, let's say if you start pitching your idea, which is, I have an amazing app idea, but first, I'm going to build the phone. Well, it would be very complicated, you know. It just doesn't work that way. So that I think what we see nowadays and what we are seeing more and more is a reorganization of the ecosystem around fundamental blocks like hardware, operating system, control software, and that basically simplify and solidify the robotics community against a solved problem. It solves chunks of problems so that companies can focus on the business of what the robot should be doing instead of building the technology required to get this MVP.
So we had a TRI on stage earlier, and they were showing off this, arm robot that could clean the place and let the dog in and wash the dishes and everything else. But the prevailing wisdom, at least traditionally, has been to focus on a single problem and solve that. Is that still the best advice for robotic startups?
Yeah.
I mean,
I think so. But I think it's very good to be general. Solve a group of problems. But the whole question is, what kind of group of problems are you tackling? What kind of, what is your strong IP? And so instead of saying you want to do, so I mean, when you try to build your ecosystem or build a group of things you want to solve, you have to do it in an engineering fashion. Very driven by the amount of capital you require to solve each part of the problem. And then you can start saying, well, if, for instance, I build a logistic robot and I have a very good navigation stack, well, my navigation stack, probably I can use it for warehouses, but also for retail. Probably not for outdoor, if I build it for indoor, but then it's kind of general purpose. So that would be an horizontal block. But if all the topics are mixed and you don't have a very good understanding of the cost of bringing up each part of the robot, then it can become very time-consuming and very cash-consuming very fast, especially for a startup.
Yeah, so building on that point, one of the things you see with the old guard of robotics is they know how hard it is. They've had to build it themselves, and they've done it 2 or 3 times with hundreds of millions of dollars into companies that I'm hoping we're seeing the last cycle of. I think it's really great that people believe in the long-term vision that robotics can solve all of the major problems of our time. But I think the ones that are going to win right now are really the ones that focus on a niche problem, solving it, making the technical trade-offs that aren't technical debt, but instead lead a path in their product and into the market for more.
So to, again, kind of get back to the distinction and what each of your team is doing specifically, Claire, your answer is obviously a little bit different because NVIDIA is not exactly a startup. But what problems specifically were each of you trying to solve?
So when we started out 2 years ago, we actually started out looking to build a robotics company. And I interviewed 50 of the best minds in robotics.
Your goal was to just build a robotics company?
We went through 9 different, all the way from early idea, vetted prototype, got 2 term sheet offers for 2 of the businesses, which honestly, as a third-time entrepreneur who wasn't sure if I had another one in me, I was a little scared by, because people wanted to invest in a company that would take $5 million and take 12, 16 months just to get to a first prototype. That was very scary for me. It's against all modern startup methodology. So started interviewing these founders, asking them, how do we make this faster? What have you done? And it turned out there are no, I don't know if you know the Ben Horowitz phrase, but there are no silver bullets, there are only lead bullets. Same thing applies here. And so the building blocks that we learned every company had to build, we ended up turning into a company because we got the best practices from all the companies we could talk to, and then just started building the ones that more people needed.
What problem did NVIDIA see, and why did it feel like it was kind of uniquely positioned to solve it?
So the problem we are trying to solve is much more about workflows that you require to develop a robot than, I would say, technological blocks. So we focus a lot on what we call workflow. And a workflow is when it's a number of points, touch points that you require to develop a robot. And so some of the workflow that we work on, a very important one is embedded, which is in the end, whatever you build has to run on an embedded platform. And today, a lot of people are either embedded or desktop people. And those are two categories of skill set, and the tools are different. You have to cross-compile and do this kind of stuff. So one of the things we did is we made sure that we developed a software called Isaac that is extremely well optimized to run on embedded platform. So we call it the nervous system of these Jetson platforms. But you can develop everything on the desktop using simulation. So you don't have to be an expert and understand how to accelerate workload using hardware accelerator or computer vision accelerators. It's just transparent. Because if we know what you want to do and you can sketch your application on the desktop, we can make the right, because we know very well the hardware, we can make the correct optimization so that we transfer it to the embedded system without having to look too much into the detail of the embedded. One other major workflow we do is training in simulation. Just because most of the products we have today are planes or cars or space shuttles. They're all using simulation to bootstrap the process and to basically test the system exhaustively and make sure that you push in the system a wide variety of data, so you exercise every single part of the software and you can detect failure. And that's something else that we integrate very well, so that you don't necessarily need the robot with you, the physical robot, to start testing your system.
I think both of your teams are taking different approaches to sort of solve a similar problem, in that to create a kind of more unified solution for people who are building robots. Do you feel like the industry, as we're moving along, though, is becoming more or less fragmented? Obviously, a lot more people are getting into the space, but with all of these, platform plays, are things becoming more unified?
Yeah, yes and no.
Yeah, definitely yes and no. Take industrial arm manufacturers. So far, to date, and we talked to the highest of the highs, there hasn't been a reason for an ARM from FANUC and the controller system from that to work with ARMs from ABB and the controller system for that. And that, at an industry point, is definitely holding us back, because it means that anytime you want to integrate new hardware that is not NVIDIA, you have to go out and integrate a brand new API, rewrite your software, and make sure it all works in production, well, first in testing, then in production. And so you see fragmentation with some of the last generation robotics companies that continue to have more success. But then I think you're seeing like some of the movements in ROS 2 and the ROS Industrial and even NVIDIA, the image for the Isaac that you can download, it's Ubuntu, it runs ROS, and it has these things pre-baked in. And if you go back a year and a half, it used to take 2 weeks if you're a modern software developer. So it's using
existing open source platforms as kind of a building block.
Yeah, and we're seeing the move of, I think we're seeing
that was yeah, maybe.
So,
you feel free to disagree with me.
Yeah, so actually so you can't, Isaac is different from ROS. So it's a much smaller code base with very few dependency, and we optimize it very well just for our hardware. It's completely interoperable with all the open source, but it's really different from ROS.
Yeah, so that's a piece that I was trying to talk towards.
All right.
I was hoping, it's the last panel of the day, so I was hoping there'd be like fisticuffs afterwards, but I think we've settled that.
So, but to go back to the fragmentation of the ecosystem, we are gaining so much momentum in robotics thanks to self-driving that we can see there is an explosion of like new machine learning, new hardware, new dedicated SoC to do machine learning, new simulation. So we can new sensors, of course. So we can see that the ecosystem can look more fragmented and more isolated also, but in the meantime, there's there's now a better picture of like what makes sense to group together. And one thing for sure, you do not want to rebuild your mobile phone each time. And maybe the mobile phone is not a very good analogy because there's no actuators. But the brain and the way you perceive the data and bring it to the brain and do some kind of basic computation, this is universal. Like every robot needs a very similar architecture plus software plus hardware architecture. And I would say robots who require that are not only a Terminator robot or a vacuum cleaner, but it can also be, when you see a factory, it can also be an assembly of 4 arms and 32 cameras and a conveyor belt. This is a robot. This is also a robot. And the requirements in terms of hardware, compute, sensing, and actuation are very similar for this system and a very small one.
I like
that's, you know,
yeah.
You can see there is an alignment here.
I like the smartphone analogy from the standpoint of, you know, a few years ago I was at a Harvard robotic hand research facility, and they were using a barometer that was invented for the smartphone. Because of the smartphone race, these things have come down considerably in price. It sounds like there's an echo in what's happening in autonomous vehicles.
Exactly. And that's how ecosystem, or this is how new markets are emerging. This is by this accumulation of scale economy on pieces of software and hardware, where basically, well, that's a platform. When we say a platform, this is exactly what it means. It means you have this foundational brick that is so stable that you don't even have to care about knowing what's under. It just works. And then you can step on it and start building on top of it.
So I think the point here is that the defragmentation is happening, but it's not evenly applied. So the compute is getting cheaper, it's democratization to the software and the hardware, but then sensors, actuators, those are pieces people are largely having to build themselves when they start out to make a consumer-grade robot today.
It sounds like you're both really targeting, you know, startups to some degree. And, you know, if I was running Amazon Robotics or Google Robotics or, you know, any of these big ARM companies, I had the resources to build a full stack. So why wouldn't I kind of build out my own, you know, proprietary stack? Do you foresee the bigger companies sort of jumping on some of these more kind of open source universal platforms?
Yeah, absolutely. I think it will come. The problem today is the maturity of all these solutions and the ability to actually bring into production. And sometimes I think depending on the problem set you're trying to tackle, today it can be cheaper and easier to restart from zero for a big company if you have the right team than trying to fix something that doesn't really work well for you. But I think as time comes and you know and a lot of things are given, or like a lot of platforms are given to the community or available for a lot of people, then it just doesn't make sense to develop it again, because you have the proof that someone was successful with it already. And then when the decision maker is looking at the budget for a team, then the question would come, which is, well, are you really sure you have to build yet another camera, depth camera, for instance? Well, depth camera probably, but like mono camera. Are you really sure you have to like get your custom lens and your custom, CMOS sensor and your custom requirements? Why don't you buy one?
There's a little irony in the fact that there's a lot of different companies taking very different approaches to universal open source products, right? I mean, there's all these people trying to solve this problem. Does there need to be the role that Google played in the Android ecosystem? Does a big company need to come in and solve that problem?
That's a really great question.
Maybe. It's possible, but I would love to think that it's going to be a little bit different, just because, and that's why I think the analogy to the cell phone is not completely correct, which is, interestingly, one of the problems of robotics is There's so many different kind of robots. They all have a different body. And somehow we have to extract what is common to this 80% and make it work for most of the robots. And this exercise is very hard.
We were just like a real quick anecdote. We were backstage, and they were fitting us for the mics. And we're all people, you know. We're all the big, you know, in a sense, basically the same model, but you know, there's still a lot of leeway there between the size of people's heads and their ears. There's a lot more differentiation between robots.
Yeah, that's right.
That's a problem that you're trying to solve.
Yeah, and I think one of the important things, there's a lot of, take the self-driving car as an example, there's a lot of talk about autonomy right now. It's not clear whether we're 2 years, 5 years, 10 years, or even 30 years away from full autonomy. I think the smartest companies that we're seeing right now are the ones who are setting the engineering spec to be 99% autonomy, and then are building tools or using off-the-shelf tools to have human intervention or human in the loop at the right time. And that way you can solve, and like you said earlier, you can build a real business right now today with the technology we have today and evolve that business as technology gets better.
A 99% accuracy rate is not good enough for self-driving cars.
It's not good enough for a coffee shop.
Yeah.
That means you have to have a full-time person there.
Well, it depends where you deploy your self-driving car. It's necessarily not good for if you are on the public routes, but if you are on a private park, and then you can afford to stop because you go slower than other vehicles, for instance, it might be acceptable.
Yeah, and then for the coffee shop, if you don't want to have to employ a full-time employee in what's supposed to be an automated coffee shop, if you have remote intervention, tools that people are building now, then you can deploy that now. Then you can build a business off of it now, and you can have fresh meals. There's a place here in Berkeley that's an automated, they make sandwiches and coffee, and they can use remote intervention, so they don't have to have a full-time person there. And then all of a sudden, this becomes a viable business, and the numbers are better than competitors.
So what is your specific solution to dealing with, you know, again, the fragmentation of robots? I mean, you're trying to build a platform, and one of the many things you're trying to do is build a sort of like a deployment platform, right, for a very broad swath of different devices.
So we started out, and the first couple, when we interviewed these 50 founders, the first two pieces that people had to build were, I need monitoring, I need to see all my telemetry for all of the sensors and data in one place. And then I need control. I need control locally because as I'm building autonomy, I need to be able to drive the robot with a joystick. Then in first production, you see I have to do these things remotely, and I have to intervene at even more critical times, so I need to be alerted. So we built a set of tools to do that. And our approach, and where I'd like to see us in 2 years, is to be the last API that any robotics company has to interact with or has to install, because we need to, as a company, have software that works with the places people build robots now and the places where people are building robots next year, and so on.
So we're basically out of time now, but I think this is a really good place to end because you both have these things that are out in the world right now, and all of these people here can use them and go out and start building robots. Great. Thank you so much for joining us.
Thank you.